Welcome back to another video. Let's jump right into the topic of basic set rules and probabilities. The complement set rule in probability refers to the relationship between an event A and its complement not A, which includes all outcomes in the sample space S that are not part of A. The complement of set A can be represented as A prime or AC, which reads as not A or A complement. The complement rule states that the likelihood of event not A occurring is equal to 1 minus the probability of A. For example, when rolling a six-sided die, if event A is defined as rolling an even number with outcomes 2, 4, 6, then its complement A includes the odd numbers, outcomes 1, 3, 5. If probability of event A is equal to 0.5, then probability of A complement or not A is 1 minus probability of A equals to 1 minus 0.5, which is equal 0.5. The complement rule is valuable for simplifying probability calculations, especially when dealing with complex scenarios, by allowing us to calculate the probability of the complement event instead. The intersection of two events refers to the set of outcomes that are common to both events. In probability, it describes the scenario where both events happen at the same time. For two events, A and B, the intersection of A and B, denoted by A intersection B, is the set of outcomes that are in both A and B. The difference between events A and B, also called the relative complement of B in A, includes all outcomes that are in A but not in B. Probability of difference is calculated as probability of A minus the probability of A intersection B. Subtracting the probability of A intersection B removes the probability of outcomes common to both A and B, leaving only the unique part of A. For example, if event A is defined as rolling a number less than 4 on a die and event B is defined as rolling an even number on a die, A minus B means rolling a number less than 4 that is not even, and it would be 1, 3 with a probability of 2/6. The union of events A and B represents all outcomes that are in either A, B, or both. In probability terms, probability of A union B is equal to probability of A plus probability of B minus the probability of A intersection B. As shown here, the subtraction of the probability of A interaction B ensures we don't double count the overlap between A and B. The associative rule in basic probability rule states that the way we group events in unions or intersections does not change the result. This means the grouping of the events does not matter when calculating the union. In union, the associative rule implies the union represents all outcomes that belong to at least one of the events, A, B, or C. Similarly, the grouping of the events does not matter when calculating the intersection. The intersection represents all outcomes that belong to all three events simultaneously. The distributive rule in basic probability connects union and intersection operations, showing how one operation can distribute over the other. It works similarly to the distributive property in algebra. The distributive rule of union over intersection means that taking the union of A with the intersection of B and C is equivalent to taking the intersection of A union B and A union C. On the other hand, the distributive rule of intersection over union means that intersecting A with the union of B and C is equivalent to taking the union of A's intersection with B and A's intersection with C. The double complement rule in probability theory states that taking the complement of a set, or event, returns the original set. It is based on the idea that negating a negation brings you back to the original state. Identity rule for intersection covers the intersection of an event, A, with a universal set S, or the empty set, which follow these rules. First, since the empty set has no outcomes, so there's no overlap between A and the empty set. Second, since universal set S contains all possible outcomes, the overlap between A and S is just A. The idempotence rule refers to the fact that performing certain operations on a set, or event, with itself does not change the set. This applies to both union and intersection operations. A union A is A and A intersection A is also A. Dominance in intersection states that the intersection operation with the empty set and any event returns the empty set. There are two main De Morgan's laws, one for the complement of a union and one for the complement of an intersection. De Morgan's first law: the complement of the union of two events is the same as the intersection of the complements of those events. In other words, the outcomes that do not belong to a union B are exactly the outcomes that do not belong to A and do not belong to B. De Morgan's second law: the complement of the intersection of two events is the same as the union of the complements of those events. In other words, the outcomes that do not belong to A intersection B are exactly the outcomes that do not belong to A or do not belong to B. Thank you for your attention, and see you in the next video.